Hi everyone, I'm Soicho. In this demo video, I will walk you through 3 tasks using GeoGebra 3D calculator. For the first task, we will graph the function f of x and y. Second, we will create a contour plot for the function f of x. Lastly, we are going to graph the tangent plane to f of x and y at the point 2, -1, and -3. All right, let's get started. So we will we will just search it on your preferred browser and just click the first link, and then it will navigate us to here. For the first step, we need the 3D calculator, so we will switch it to 3D calculator. Then I will graph the surface by entering the function into the input section. Our given function was f of x and y was half 1/2 x cubed negative y cubed plus x for xy. So here's the given function, the graph for the given function, and then we notice that like the bottom part is missing here. So we will adjust the x's. So I will change it to from -5 to 5. For all of the x's. All right, cool. It looks way better. Now we can see the settle shape. So this purple surface is the surface for the given function. The given function, and then this settle shape was made by the cubic term and the mixed term. All right, for the first task, I think that's all. And then in the second task, we need the graphing calculator to create the contour plot. So we are going to create a contour plot by putting the same function, x squared negative y cubed of plus 4xy. And then now we have to plug the z value, which is just going to be a constant. It means also like by putting the different z value, we are meaning like different height. So each function is showing the different height correspond to the each different z value. All right, I put like 7 different z value, and then we can now see the contour plot on the right side. So each function, each curve implies each curve implies the different height, which is the z value, and then I color code them to make it more clear. And then as you can see some curves form loops, especially at the origin. If I zoom out, mostly it's flat, just like the origin. Around the origin there are some looping and curvy curves, and then others kind of stretch it out too. This tells like this contour plot tells us how the function increases or decreases in different reason. It is also similar to a topographic map, and then helps us understand where the function grows steeply or remains flat. All right, let's be let's do the third task. To graph the tangent plane to f of x and y at the point, we have to get the total derivative by doing the partial derivative for each variable. So if you do the partial derivative respect to x, you will get 3 halves x to x squared plus 4y. And for the partial derivative value respect to y is going to be negative 3 y squared plus 4x. And then we plug this point, then the two negative 1 and negative 3 values into the total derivative we just got. Then we will get 2 for f sub x and 5 for f sub y. Then now, and then finally we can also plug the same points into just the given function without any doing the partial derivative. And doing partial derivative, and then that's gonna be our first term for our tangent plane. So let's switch it to the 3D calculator again. Then now we can plug those values we just got. So it was negative 3 after plugging the points values into the given function. You will get negative 3, and the value we got after plugging the numbers into the partial derivative term, and x minus 2 x minus 2 plus 5 y plus. Those are the given points. So all right, then now we can see the green tangent plane. Then we will I will enter the points 2, which was 2, -1, -3. All right, so we can see the point here. So I plotted the point A to confirm the point of the tangency. And then as you can see in the graph, the green tangent plane touches the purple surface at exactly the point, and then shapes the same slope. It means it confirms that it is truly tangent, as we can see here. It looks better. Yeah, the tangent plane really touches the surface, the purple surface, which was the given function surface, at exactly the point we are given. All right. Oops, I moved it. Let me plug that again, just to make sure. Okay. All right. It looks better. So to summarize them, what we've done so far, first we graphed the surface and identified the saddle shape for the first task. Second, we create a level contour plot with the multiple height level. And we demonstrate that the tangent plane touches the surface precisely at the given point A with the matching slope. I hope this demo helped you better understand 3D surface and tangent planes in multivariable calculus using GeoGebra. Thanks for watching.